Hello folks, Peter Lawn here. Welcome to my tutorial series on how to use Blender to build bases in No Man's Sky. This is part 5 of the series and it's going to focus on more advanced building techniques using Blender and the Blender plugin. This tutorial is designed for PC users only, and if you are unfamiliar with the software needed, please check out parts 1 to 4 of the series, which includes workflow overview, installing the software, and the basics on how to use Blender and the Blender No Man's Sky plugin to create awesome bases in No Man's Sky. This session will focus on a few tools and techniques I've used that you might find useful as you get more familiar with the Blender and the Blender plugin. So the first topic we're going to look at is something called a perfect circle of anything. A lot of online content shows these great No Man's Sky base builds that have some sort of circular structures or arrangement of objects. Today I'm going to show you a few tricks to build a perfect circle of anything with any number of sides. The trick is using the following formula. Radius of your circle is going to equal to the width of an object divided by 2 all over the tangent of the angle of the object rotation divided by 2 times pi divided by 180. And all of that is tangent. This formula is the trick to everything. You can calculate the radius of your perfect circle of anything knowing the number of sides you want and the width of those sections. I would suggest you set up an Excel spreadsheet like I did, which will do the calculations for you, given the user entered data of number of sides and width of the object like this. You can see the angle is calculated using 360 divided by the number of sides you want, and the formula will calculate our radius. In this case, I want a 16-sided circle with a width of an object at 4, which would yield me an angle of rotation of 22.5 and a radius of 10.055. Let's see this in action now. We'll switch over to Blender and use an example of a glass floor plate standing on end, and I want to create my perfect circle with this floor plate. I start by placing the object in the correct orientation that I want. I'll now check the width of my object along the x-axis, selecting the floor plate, and then looking at the Item tab at the top right side window display. If you don't see this menu, hit the N key to toggle it into view. I can see this object is 5.33 units wide along the x-axis. I will enter this value into my spreadsheet, and I'm going to keep 16 sides to my circle. I can see that my angle will be 22.5 and my radius is now 13.398. Next, we'll move our 3D cursor to the center of my floor plate object by selecting the floor plate and using Shift plus S and selecting the submenu Cursor to Selection. We'll then move our floor plate by the radius amount along the y-axis. You can do this exactly by hitting G to move the object, then Y for the axes that we want to move it along, and then enter the radius value of 13.398 and hit Enter. This moves the floor plate exactly by the radius amount away from our 3D cursor. Next, we will set our pivot point to the 3D cursor by selecting the Transform Pivot Point drop-down menu at the top of the screen. Now you can duplicate our object and rotate it with the following commands. Shift D to duplicate the floor plate, then hit R key for rotation, followed by the Z key for the axis to rotate around. Then type in the angle of rotation, in this case it's 22.5 degrees, and then hit Enter. Just as a tip, if you're using Rotate command and you're in top-down orthographic view, numpad 7, you can eliminate the need to specify the rotation around the up-down axes as it's implied. You'll see we've copied and rotated our first piece. Blender has a repeat command, which is Shift R, which you can hit numerous times as needed to complete our circle. You can see the duplication perfectly fits the circle requirements. In some cases, you might want a slight gap between objects, or you want to overlap or tighten up the objects in the circle. No problem. Let's show you how to do that. Make sure our 3D cursor is still in the middle of our circle and our transform orientation drop down is set to local. So each object will move locally to its own axis. We want to make sure our pivot point drop down is still set to the 3D cursor. Now we'll select all circle items and hit G to move and then Y to select the axis to move along, so you can drag your mouse to move the circle objects closer or further apart in equal distances. You can use this technique to make an evenly spaced circle of anything with any number of sides. Always be aware of where the object origins are, or the median point of several objects, as this is where the width should be determined. Alrighty, up next, duplicate along curve revisited. In part 4 of my tutorial series, we touched briefly on the use of the duplicate along curve button in the No Man's Sky plugin for Blender. Today I'm going to take a closer look at this feature again to further reinforce the use of the transform orientation drop-down setting at the top of our main window, in conjunction with the pivot point drop-down setting. Both these settings are critical to understand more advanced object rotation and positioning. We'll also look at the interesting aspects of the circle curve object and how it impacts the placement of objects after this command. In this exercise, we will complete a near-perfect circle of cylinders like this, using the duplicate along curve plugin function and some cool rotation commands. Let's start by adding a cylinder object from the plugin library and placing it out here where we can work on the structure. Let's move the 3D cursor to the center of our cylinder by selecting the cylinder and using Shift plus S and selecting Cursor to Selection submenu. We'll now add a Blender curve object, and in this case we want a circle curve. Don't confuse this with a mesh circle, which will not work with the plugin command. I enter Shift plus A and select Curve and Circle. I'll size up the circle object by 15% by hitting the S key and entering a value of 15, and hit Enter to resize the circle. Let's select the object we want to duplicate along curve. Left mouse click on the cylinder and then add to the selection the curve object by holding Shift plus left mouse click on the curve. Now in the plugin menu, select Duplicate Along Curve and it will come up with a distance between item enter box. This value needs to be between 0 and 1, and I've already messed with this before in my tutorial, so I know that a value of 0.02 will work, which I enter and click OK. You now see a bunch of cylinders that will be added to follow your curve. This is great, except we need to do some rotating. We'll delete our original cylinder since we're done with this one. Let's discuss the importance of the circle object in our scene and the relationship it has with the individual cylinders created as part of the duplicate along curve command. You will notice operations performed on the curve itself will change the position of the associated objects along that curve. This is because the Python script created these objects with a constraint to curve properties. So if you size or rotate the curve, the objects will follow. You can still manipulate individual objects, but their relative position will always be tied to the curve position. When you export your Blender base, this curve is omitted and only the cylinder objects' positions are exported. Subsequently, when you re-import your base back in Blender, the curve will be gone along with any constraints that were generated in the original file. If you delete the curve at this point, the associated constraints will be deleted and you'll end up with a whole bunch of objects located at your base computer location. If you do this accidentally, just delete all the cylinders and redo the steps to get back to this point. In order for our cylinders to be rotated and lined up properly, we need to first change the orientation of the circle curve object. Let's hide all the cylinder objects and have a close look at the circle curve. Go into Front Orthographic View, Numpad 1, and box select the top parts of our cylinders and hide them for now with the H key. When editing bases in No Man's Sky with Blender, the majority of time is spent in the object mode, as we normally don't need to go into mesh editing of our base objects. You can see which mode you're in the upper left of the main display window here. Let's select our circle curve object and hit Tab key. This will toggle between object mode and edit mode for a selected object. In object mode, our circle curve just looks like a plain circle. But in edit mode, you can see our circle curve is actually made up of 4 Bezier curves connected together. We'll examine the Bezier curve more later in this tutorial in the next section. You can see this sort of herringbone pattern which describes the curve characteristics, and currently it lies flat along the X and Y axes, and our cylinder objects are pointing up from those axes. While still in edit mode, click anywhere in free space outside of the objects to deselect everything, and then hit A key to select all control handles of the curve object. Now we're going to twist these herringbones outwards by 90 degrees. We do this by hitting Ctrl T and typing -90 and enter. If you switch back to object mode with the tab key and unhide our cylinders with Alt H, you will see the effect of the circle object twist, and our cylinders are now pointed outwards from the circle center. You can see this effect in action if I redo this procedure with the cylinders showing this time. You can twist the circle curve object 90 degrees inward to the circle or outward. Both will work. We still don't have the cylinders orientated correctly, but this first step was required to get the up direction of our objects pointing in the right direction relative to the circle. Okay, let's make sure we're back in the object mode. Hit Tab to toggle, and let's hide the circle object for now. It's hard to select it sometimes when objects are stacked close, so you can also find it in the Collections and Object list at the top right window here, and look for Bezier circle. Left mouse click to select it, and move your mouse cursor into the main 3D window and hit H to hide it. For the final rotation step, we want to make sure our transform orientation drop-down is set to local. We'll also change our pivot point drop-down from 3D cursor to individual origins. This way, when we rotate, each cylinder will be rotated around its own origin and won't follow the global axes. Select all cylinders and hit R for rotate and X for the axis to rotate around. And then drag your mouse to line up the cylinders in a circle. You can make it work by rotating in either direction. You might notice that the rotation will be something slightly greater than 90 degrees. This is because our center of rotation of each cylinder object is not exactly in the center of mass of the object, but at the bottom. So this is a really important point. If the object you're duplicating along curve already has its origin, that's the little orange dot you see when you select an object, at the center of its geometry, you can skip this twist trick on the circle curve object. Most objects in Blender plugin from No Man's Sky have their origins at the bottom of the object, so this step will be required. I want to stand my circle of cylinders upright, so remember all you have to do is select the circle curve object, and all the constraint objects will follow whatever you do with that object. So let's export into the game and have a look at the effect. The Bezier curve. When we looked at the circle curve earlier, we saw that it was made up of several Bezier curves. These curves can be added to Blender and will work with the duplicate along curve command in the No Man's Sky plugin. They are particularly useful when you want to create some complex curves, or for example a large shallow curve like I did with my bridge base build. I used the Bezier curve to get the slight curve of the bridge deck as well as the suspended cables between the supports. Let's look at this Bezier curve in this section, and I'll offer up some tips for controlling its behavior. I'm going to start with my test base here and add a small cube in the center of my platform. Switch to front view, numpad 1, and raise it up a bit using the G and Z key. You'll notice when you add No Man's Sky objects in the Blender plugin, they show up at the currently selected item or at the base computer if nothing is selected. For native Blender objects, when you add items, they will add at the current location of the 3D cursor. I want to add a Bezier curve at the cube location, so let's first move the 3D cursor to the cube. Select the cube, then hit Shift plus S key and select Cursor to Selection. You can see the 3D cursor is now at the cube's origin, the little orange dot. Now I will hide the cube using the H key, and let's add a Blender Bezier curve object using the Shift plus A key and select Curve and Bezier. I want to hide everything in my scene except for the Bezier curve I just added. Select the curve, then hit Shift plus H key. This is a neat trick that hides everything unselected, so we get a nice clear view of the Bezier curve. Let's size up the curve a little bit by selecting it and hitting the S key and left mouse click and drag. With the curve selected, hit the Tab key to go into edit mode. We had mentioned before that most of the work in Blender with No Man's Sky is in the object mode, but with the Bezier curve we want to be in the edit mode. Now you can see the familiar herringbone pattern we saw with our circle object that we looked at earlier. There's a lot to absorb regarding how these objects can be manipulated, but I'm only going to cover up the basics so we can use them to create curves in our bases. So a little bit of terminology. These little dots connected with straight lines are called control handles or vertices, and each group of 3 on my segment of curve are called control points. Right now I have one curve segment with 2 control points. If you left mouse click and select the center vertex of this control point, it will automatically select all 3 vertex handles. Just like in object mode, you can use the move key in edit mode, the G key followed by the axis keys X, Y, or Z to control the direction you want to move vertices and control points. You can also just select one vertex at the end of your control point and manipulate the angle and shape of the curve using the move commands. To add more control points to our segment, simply select the end center vertex, hit the E key to extrude, and mouse drag and left mouse click to position the new control point. You now have created another new segment along with new control point. Previously, when we looked at the curve object, I may have incorrectly referred to altering the curve herringbone plane orientation as twisting the curve using the Control plus T key. The actual technical term for this is tilt, but you get the idea. You can tilt this Bezier curve as well by selecting some or all of the vertice handles and hitting Control plus T keys and mouse dragging to tilt the curve. This is all great, but my curve is starting to look like a little bit of a mess. How can I control its shape along an axis? Well, if I wanted to control my objects to be straight along the x-axis, I will look at my curve from the top view, numpad 7, and box select all handles and use this little trick. Hit the S key to resize, followed by the Y-axis key, and then hit the 0 key, followed by Enter. It's a neat little trick to line up the vertices along an axis, since a vertex can't technically be resized. So now they are aligned looking at the top view, but let's check the front view, numpad 1, and perform the same trick to align them along the z-axis. This time select all vertices, hit the S key to resize, followed by the z-axis key, and hit the 0 key, followed by Enter. And I know you're thinking, geez, Pete, this is supposed to be about creating curves and not straight lines. But when you start straight, you can control the adjustment of the curves. My control points are not centered or sized equally along the front view, and in order to have a nice curve, you need symmetry. To reposition the curve control points, I'm going to use Blender's Snap to Grid function so I can create some symmetry. You can click this little magnet icon at the top of the screen to toggle the handy Snap to Grid mode in Blender. There's also another drop down next to the icon that controls some Snap to settings. And in this case, we'll leave it on Increment and check the Absolute Grid Snap checkbox. This will snap our control points of the Bezier curve to major grid line increments. Let's also make sure we are in Global Transform Orientation mode with the drop down up here, and that our pivot points is on the medium setting. I will move this first control point by clicking the center vertex and hitting G to move, and move the mouse to drag it along the x-axis, and left mouse click to place it. Notice how it snaps to the grid for us. I'll also move each end vertex so that they are 3 units away from the center vertex, like this. We'll position the center control point and size the end vertices 3 units away each. And finally, the last one, double check they are all the same size and all evenly spaced for complete symmetry. Now we're ready for the curve. Click the center control point and move it down by a few units using the G move key and dragging the mouse and left mouse click to place. I'm going to select the center vertex of this first control point and rotate it 30 degrees by hitting R, followed by 3, 0, and enter. Do the same on the other end, except this is rotating in the other direction, so hit R, followed by -3, 0, and enter. Now you can see our curve taking shape. Once I got it where I want it, I'll switch back to the object mode with the tab key, and I'll unhide my base to get an idea of the size of the curve. If I need to, I can reposition and resize the curve as needed. With the curve in place, I can do the duplicate along curve procedure detailed earlier in this video, and now we can have a gentle curve of concrete blocks at our base. Alright, well, travelers and builders, that's it for now. I truly want to thank you for watching this video, and I hope you got something out of it. Until next time, cheers and stay safe.